Bismillahirrahmanirrahim. Dear student, like in last video we proved some formula for the projectile motion, like different formula we proved on the range of projectile, height of the projectile, component of the projectile, and so on. So in this video we are trying to solve some example about the projectile motion which we have for different types of cases. So let's see, we will solve one by one here in front of camera. So if you have any kind of question after this, and if you have any types of question, so you just take the picture and send me through on the comment, then we will solve together. Okay, let's see the first question. Here they ask, like in the projectile motion, if you watch the first video, this is about the special case question. So they ask that a ball is thrown at 10 meter horizontally from the top of a building. Like let's suppose this is the building, and a ball is thrown with a speed of 10 meter per second from here. So after some time it will start the projectile motion. So the building height is 80 meter. Find the following. The first thing is unknown here. They said the time of the flight, like how much time it will take to reach the ball from the top of the building to the ground level. The second one, distance away from the building, like how far the ball will strike the ground. Mean we will find the displacement or distance, or simple we also say the range. The third thing, the velocity of the ball just before strike the ground, and that point we will also find the velocity of the ball. So here let's see here the height. We know that in the previous video, in the first video of the projectile, we prove the one equation for the special case. This equation we said here, this side we equal y, like here I can write y is equal to h mean height, and this is equal to y. Now this y is equal to mean height is equal to 1 by 2 gt square. Now if we put the value here, so what happen, 1 by 2 g acceleration is meter per second square, and the value of y is 80 meter, so multiplied by t square. So now if we divide the 10 by 2, so the value will be 5 meter per second square into t square, and here is 80 meter. Now if I want to find the t square, so I can write this equation like 80 meter divided by 5 meter per second square. So meter will be cancelled with meter, and 80 divided by 5 is 16. Now the remaining thing is second square. So this is t square. Now we have 16 second square. So if we take the square root, so it will become 4 second. Okay, the next one, if now this is the time, the first part is the a part is finished. Now we will find the time. Sorry, we already find the time. Now we are going to find the displacement, mean the range. So we know that from the special case, this formula we already derived. So delta x is equal to vix. Here this velocity is equal to 10 meter per second, and the time now that we find is 4 second. So second will be cancelled with second, and 4 multiplied by 10, our displacement will be equal to 40 meter. So this is the displacement, or the distance away from the building. Now the last thing, they said the final velocity. They ask about this one. So we know that from the first video, if you watch the first video of the projectile, so we prove the formula for the final velocity. Vf is equal to f of x plus f of y. Now this f of x is equal to vi x, mean this one, this part or this part. So this is equal to 10 meter per second, because on horizontal we know that the velocity is constant, and this is the horizontal component. For the other hand, Vfy, if we put the formula here, so here on this case Vi y velocity, mean this part, is equal to 0. So that's why I put 0 and multiplied by gt. So g value is 10 meter per second, multiplied by time is how much? 4 second. So if we multiplied this one with each other, so this one is second square, second will be cancelled with square. So here Vf is equal to 40 meter per second. Now the final velocity, if we put the value here like this one, so this is equal to 10 meter per second, 10 meter per second whole square plus 40 meter per second whole square. So now this value is equal to 100 meter square into second square plus this value will become 1600 meter square into second square under the root. So if we add these two values, so this will become 1700 meter square into second square. So if we take the square root of the 1700 value, so this will become 41.23 meter per second. So now this is the final velocity when they hit the ground at this point. So this is the 41.23 is the final velocity if we calculate this one. Okay, this is the question number 1, which is related to the special case. On the next page we are going to discuss the second question. Now what they ask in the second, what they want in the second question, find the horizontal and vertical component in velocity of velocity and displacement of the object after 5 seconds and find the final velocity. Okay, let's see here. Very simple. Like for the component of vector, you know that already we discussed so many times. So here the velocity is for the horizontal, this is the horizontal component, this is the vertical component. Now we just putting the value here. So initial velocity here is 50 and cosine of meter per second dot cosine 53. So if we multiplied 50 meter per second dot cosine 53 is equal to 0.6. If we multiplied these two value, so this component is equal to 30 meter per second. So this is the horizontal component, 30 meter per second. Now if we multiplied this two value by putting the value, this is 50 meter per second. Now sine 53, so 50 meter per second multiplied by sine 53 is equal to 0.8. So if we multiplied 50 and 0.8, this will become 40 meter per second. So this is the vertical component of the velocity. So this is horizontal component, this is the vertical component. Now we prove horizontal and vertical component of the velocity. Now after this they ask the question, displacement of the object after 5 seconds, mean displacement after 5 seconds. Now this simple formula is we have given vi t. So now in this case vi is equal to vi cosine theta on the horizontal side. So delta x will be equal to mean if we use the special case formula, so we know that vi is equal to vi cosine theta, horizontal component is same. So if we put the value here, delta x is equal to vi cosine theta. Now this part we already proved, this is equal to 30 multiplied by the time is also given here is 5. So 30 multiplied by 5 is equal to the value is given here, this is 150 meter. If we multiply this to, so this is the displacement. The last one which we are going to find the final velocity. So again for the whole at any point, if they ask if they want to find the final velocity at that point, like this one, if they want to find the at this point, so this formula will be used for the final velocity, v of f x plus v of f of y. This formula, sorry, there is no under root, so simple v of fx and v of f of y. So v of fx, again in the previous question also we use this one, this is equal to the horizontal component, this one, and this is equal to vi cosine theta, which is equal to 30 meter per second. So this is very simple, but vfy component is a little bit, this is not equal to exactly this one, this is the difference. Here is the difference, vfy. In this case we have we will use this formula, vi sine theta minus gt. So now vi sine theta, we already proved this, this is equal to 40 meter per second. Now 40 minus g value is equal to 10 meter per second square. In the time is 5 second. So this is also meter per second. So second square will be cancelled with second, and 10 multiplied by 5 is 50. So now 40 meter per second minus 50 meter per second. So the second component of the final velocity, vfy side, will be equal to minus 10 meter per second. So this is the second component of vertical component of the final velocity. Now putting the value, vf is equal to vf x square plus vf y square under the root. So here if we put the value, so this is 30 meter, this one, this is already given, 30 meter per second whole square plus the second one is 40, which we no sorry minus 10 meter per second whole square under the root. Now this will become if we take the square, 900 meter square per second square plus minus, no sorry, this will become plus, so plus 100 meter square into second square. So if we add these two values, so this will become it will become 1000, it will become 1000 meter square into second square. So taking the square root of this value, so this will show the final velocity of the object when they at any point. You can use this formula. So this is the question number second. The third one which we are going to discuss here, the last one, here they ask find the maximum height and maximum range of the projectile. So now we are going to find the maximum height, mean this height from this point to this point and this range. So we know that the height formula that we proved in the last video, vi square into sine square theta divided by g. Now vi here is 10 meter per second whole square. Sine 2 we can write like this, sine theta multiplied by sine theta 2 time, we can write this 2 time divided by g. Now putting the value here, so this will become 100 meter square into second square, and sine 37, so the angle is 37 and sine 37, so sine 37 is equal to 0.6. So if we multiply this value 0.6 and 0.6 divided by 10 meter per second square. So now this will become, here is 100, this will become, if we multiply these all things, so this will become 36 meter square into second square divided by 10 meter into second square. So this will cancel with this one, and meter will be cancelled with meter, so 36 divided by 10, which is equal to 3.6 meters. So this is the height, this is the range, this is the maximum height of the projectile if the initial velocity is 10 meter and the angle is 37. Now we are going to find the maximum range. So we know that range formula is equal to vi square sine 2 theta divided by g. So now putting the value again, so initial velocity is 10 meter per second whole square dot sine 2 multiplied by 37, 2 multiply, the theta is 37, so this is equal to 74. This means that we will find the sine 74 degree divided by 10 meter, putting the value of g, 10 meter per second square. So now calculate this value again, find the sine 74, so this is equal to 100 meter square into second square. Sine 74 is equal to 0 point multiplied by 0.94, this is equal to 0.94 divided by 10 meter per second square. So cancel the unit, this will be cancelled, meter will be cancelled with that one, so 100 multiplied by 0.94, this is equal to 94. 100 multiplied by 0.94, this is equal to 94 divided by 10. So now the range or this displacement is equal to 9.4 meter. So this is the solution of the 3 question. Hope you got some point from today lecture as well, from the example. Thank you so much for today lecture. And also if you have any types of question related to projectile motion, so you can ask directly, take the picture of the question and you can ask. So thank you so much for today lecture. Be stay with us. Thank you so much.